All right, so let's pick up where we left off with question G. Where were we? Oh yeah, so we were on this screen, and I left off the text from the textbook's PowerPoint document. So I'll have to do this makeshift. Part G of this question asks us to graph f of theta equals cosine theta well, that's our standard cosine of theta graph with amplitude of 1, and at 1, 2, 3, 4, 5, 6, 7, 8. That just isn't going to cut it, is it? See if I can get nice equal spacing here. Okay, that would be 1 radian, 2 radians, 3, 4, 5, 6, 7, 8 radians. And if we were to graph f of theta equals cosine theta, that is going to be, we're going to complete a cycle after about 6.28, so up to about right there. And our amplitude is going to be 1, and let's see, so at about pi 3.14 we're going to complete half a cycle, so we might have graph might look like that, and then after 2 pi we will have completed a cycle. Now for f of theta equals cosine of 4 theta, we are going to have completed 4 cycles in the same amount of time. So we already determined in the last part of this question that we're going to complete a full cycle after pi over 2. That's about 1.57. So we'll have something that looks like that, and then we'll have completed another cycle after pi, and then another cycle, and then after what took cosine theta 2 pi to complete 1 cycle, we'll have completed cosine of 4 theta, we'll have completed 1, 2, 3, 4 revolutions. Again, this was part G of this question. So I figured I might as well throw it in here. There's a part H of this question and a part I for this question. And it says, what is the period of f and the period of g? Well, the period of f has period 2 pi, and the period of g is going to be a fourth of that. 2 pi divided by 4 would be, has period of pi over 2 for 1 revolution. Part I asks us, the tire valve always sweeps an angle that is 4 times greater than the pedal. Explain why the period of G is less than the period of F. And the answer to this question is, in 1 cycle of the pedal, we know that's going to correspond to the tire valve. So if we go our pedal 1 time, that's going to correspond to our wheel. Our wheel going around once, twice, 3, 4 times, right? So 1 to the pedal corresponds to our change in 4 of the tire valve. Okay, so I've decided that I think we'll address part A here, and then we'll pick it up in the next video with 5 part A and move forward with this question, because this question is kind of lengthy. But so we have our bike technician changes the gear ratios on the same bike from question 4 so that the wheel has a different rate of rotation relative to the pedal rotation. So consider this function h of theta equals cosine of theta over 2 times 12.5. So now we're dealing with a circular path driven by radius 12.5. And this defines the horizontal distance of the tire valve on the wheel from the vertical axis in terms of the pedal angle in radians swept out counterclockwise from the 3 o'clock position. And I think this, what they're asking here is straightforward enough. It says, what does theta over 2 represent? Theta over 2 represents the measure of the angle swept out, I'll abbreviate, counterclockwise from the 3 o'clock position. We'll pick this up in the next video.